2/3 of sequences. Now we're going to get into kind of the real basis of sequences and how we express sequences. And we saw a little bit of this yesterday in class with Dino for arithmetic sequences. And I kept saying in class how this is the explicit version, but there can also be a recursive version. And that's what we're going to look at in this lesson. So recall, given the sequence -2, comma 2, comma 6, comma 10, find part A, the next three terms. Well, in order to do that, we got to figure out what is the pattern that's going on here. It looks like we're adding by 4 each time, right? -2 to 2, 2 to 6, plus 4, 6 to 10 is plus 4. So to find the next three terms, 10 plus 4 is going to be 14, and then 18, and then 22, and so on and so forth. Not terrible. What type of sequence is it and why? Again, there's two types of sequences. There's geometric and there's arithmetic. This is arithmetic. Why is it arithmetic? Because the pattern is adding. We're adding. It's a common difference of 4. Right? That's how much I'm going up by each time. What is the formula of the sequence? Well, again, this is where we use Dino. The difference between the terms, we said, was 4, right? So again, we always write it as A sub n. So the formula starts with A sub n. This is where Dino comes in. The difference between the terms is 4. And then we put our n. And then we do 1 before the first term. Well, what was 1 before the first term? What came before -2? It had to have been -6. So our formula is A sub n equals 4n minus 6. Okay. What type of function does the sequence represent? Well, anytime it's arithmetic, it represents a linear function. And then what is the 100th term of the sequence? All I got to do is substitute into my formula. It wants me to find the 100th term. So that's what this stands for. What is the 100th term in this sequence? So I just got to substitute in 100 for n and then solve it. 4 times 100 is 400 minus 6, and that's going to be 394. That is the 100th term in that sequence. Right? Nice little review. And let's take a look at ways to express sequences. Again, 2 ways. The first way is explicit formula. And what this means, it's a formula that allows computation of any term. Any term, A sub n. In other words, I can plug in any number I want, just like I did up here, 100. Right? And here's an example. It's giving me the explicit way of this sequence. A sub n equals 2n plus 5. So, if I'm looking for the first term, what I did, here's the first term, they plugged in A sub 1, and they're plugging in 1 for n. So it's 2 times 1 plus 5. Well, 2 times 1 is 2. 2 plus 5 is 7. That's where they got 7. How about A sub 2? Well, it would be 2 times 2 plus 5. Well, 2 times 2 is 4. 4 plus 5 is 9. And so on and so forth. A sub 3 would be 11. A sub 4 would be 13. A sub 5 would be 15. And again, look at how they actually got this formula. they used dino, right? The difference between the terms, well, that's 2, 7 to 9 to 11 to 13. There's the n. And then the plus 5, that's 1 before the first term. In other words, that's this term here. It's basically like saying, what is a sub 0? Well, it turned out to be 5. Okay? So this is very similar to evaluating functions, right? Function notation, f of x, that kind of thing. And now let's look at recursive formula. Recursive formula is a little bit different, and there's a very distinct way we can tell apart explicit between recursive. Let's go through the definition. Recursive formula is a formula that allows any term to be computed from the previous term. Okay, you can compute any term you want, but you need to have the previous term, and you must be given the first term, a sub 1. Okay, you must be given the first term in order to find any term using recursive formula. So this is the way every time. This is the way recursive formula is going to look. You're going to get two different things. You always need the first term, and then it'll give you what is the next term, right? So actually, let's write this down. This is key. For explicit formula, right? Make sure you guys write this down. Explicit formula, you're only given one equation, right? And that's the a sub n equals 2n plus 5. For recursive formula, right, we're given two equations. And that is super critical to be able to recognize. Explicit formula, only one equation. Recursive formula, you're always given two equations. In this case, you're given the first term and then a sub n. Here are your two equations. That's the way you differentiate between explicit and recursive. Okay? So, taking a look at this again. It's giving us a sub 1 and then a sub n, and it wants us to fill out the rest of this sequence. So this is saying, here's a sub 1, here's a sub 2, here's a sub 3, and again, when I say a sub 1, a sub 2, a sub 3, I'm referring to the term in the sequence. Which term is it? This is the first term, this is the second term, third term, fourth term, fifth term, so on and so forth. So here, a sub 1 is given. That's nice. But how am I going to find a sub 2? Well, it's actually quite simple if you can pick up on it quickly, but again, it takes some time, it takes some practice. If I want to find a sub 2, right, I am looking at this form here. I'm looking at a sub n equals a sub n minus 1 plus 4. And what is a sub n minus 1? Well, all this is right here. That stands for the previous term, a sub n minus 1. Okay? The previous term. I'll highlight that as well. And then the a sub n, well, that's just finding any term you want. I could plug in 2 if I want to find the second term, or I could plug in 97 if I want to find the 97th term. So, let's go back to pen. I want to find the second term in this sequence. What I'm doing is I'm taking my previous term, which was a sub 1, which is 5, and I'm adding 4 to it. So I'm really doing 5 plus And the way that would look would be just 5 plus 4, right? Because a sub n minus 1 is my previous term, which was 5, and I'm adding 4 to it, which is 9. For a sub 3, I'm taking the previous term, which I found to be 9, right? And I'm adding 4 to it, which is 13. For a sub 4, I'm taking my previous term, which was 13. I'm going to move this down a little bit. And I'm adding 4 to it. So you see the pattern here. I'm taking the previous term and I'm doing whatever the rule tells me to do. It says add 4 each time. Okay, I'm going to add 4 each time then. And then the last one, a sub 5. Well, I'm taking the previous term, which was 17, and I'm adding 4 to it. Okay? So that's recursive. And if that was a little fast, we will do a lot of exercises with it. I've never lied to you about that. So bear with me. Here's some examples. Number 1, write the first 3 terms of the sequence a sub n equals 3n minus 1. I think we're getting good with this. Again, this is our dino, D-I-N-O. In fact, I want to find the first 3 terms. Well, the first one, a sub 1, again, I'm going to substitute in 1 for n. So it's going to be 3 times 1 minus 1. Well, 3 times 1 is just 3. 3 minus 1 is 2. There's my first term. How about my second term? A sub 2. It's going to be 3 times 2 minus 1. 3 times 2 is 6. 6 minus 1 is 5. And my third term, a sub 3. That's going to be 3 times 3 minus 1. And that's going to be 8. Okay. So there are my first 3 terms. Now, try and be aware of what kind of formula they give you. Here, they gave us a sub n is equal to 3n minus 1. It's only one equation, right? And we said up here, one equation is always explicit. So, for number 1, they gave us an explicit formula to work with. Number 2, list the next 3 terms of this sequence. A sub 1 equals 5, and a sub n equals 2 times a sub n minus 1 plus 3. Look how many equations they gave us. They gave us 2 equations, which means we're working with recursive for this one. Okay? It wants us to list the next 3 terms of this sequence. Right? Well, for recursive, it always gives us the first term. Right? We know that a sub 1 is given. It's 5. But we got to find a sub 2, a sub 3, a sub 4. Those would be the next 3. Let's break this down. So a sub 1 is given, right? That's my 5. If I want to find a sub 2, the rule is to do this. Take 2, times it by the previous term. Whoops, I highlighted too much. Take 2, times it by the previous term. That's what a sub n minus 1 means. And then add 3 to it. Okay? So let's do that. For a sub 2, I want to find the second term in this sequence. Well, I'm going to take 2 first off the bat, multiply it by the previous term. Well, my previous term was 5, and then add 3 to it. 2 times 5 is 10. 10 plus 3 is 13. So the second term in my sequence is 13. Let's find a sub 3. Following the rule again, I'm going to take 2, multiply it by my previous term, which now is 13. Right? This is now my previous term. And I'm going to add 3 to it. Well, 2 times 3, or 2 times 13 is 26. 26 plus 3 is 29. And one more, a sub 4. Following the rule, 2 times my previous term, which now is 29, plus 3. 2 times 29, I believe, is going to be 58, and then 58 plus 3 is 61. So those are the next 3 terms of our sequence. We would have 5, 13, 29, and 61. Okay? Those are the first 4 terms of this sequence. Let's go on to the back page. Okay. In 3 through 6, a sequence is described. Part A, identify this sequence as recursive or explicit. And then part B, find the first 3 terms of the sequence. Simple enough. So, number 3. Right off the bat, I see it's giving me 2 equations. Therefore, I know that is recursive. Right? It's giving me 2 equations. I know right off the bat, part A has to be recursive. And then part B, find the first 3 terms of the sequence. Well, the good thing about recursive is that it always starts off by giving you the first term. So kind of like a little boost, right? It's saying R sub 1, which again is fine. A sub 1, B sub 1, C sub 1, it's all the same thing. So it's giving me the first term to be -4. How do I find the second term? Well, I'm going to follow this rule. R sub n is equal to -3 times R sub n minus 1. And what I'm highlighting in green, all that means is the previous term. Right? So it's -3 times the previous term. So let's do that. So we're going to have, for R sub 2, I'm taking the rule, I'm doing -3 times the previous term, which the previous term was -4. And that comes out to +12. R sub 3, -3 times the previous term, which was 12. So -3 times 12 is -36. So the first 3 terms in the sequence is -4, 12, -36. And if you could see, it didn't ask us for this, but this would be a geometric sequence because we're multiplying, right? I'm not adding, but I'm multiplying by -3 each time. All right, I think we're gonna do number 4, and then we will stop for this video and we'll finish the rest of it for the next day. Number 4, part A. Well, I see 1 equation. That tells me it's got to be explicit. And part B, find the first 3 terms of the sequence. No problem. This is the same thing as Dino right here, right? This is just like basically evaluating a function. T sub n, well, first I got to find T sub 1, T sub 2, and then T sub 3. So I'm just going to substitute in 1 anywhere I see n. So it's going to be -6. Substitute in 1 for n, cubed, minus 48 times 1. negative 6 times 1 cubed is just negative 6, and negative 6 minus 48 is negative 54. T sub 2, I'm going to do negative 6 times 2 cubed minus 48 times 2. And again, if we had our calculators, we could just plug this right in, right as we see it, right? And the calculator would tell us this would be negative 144. And last, t sub 3 is negative 6 times 3 cubed minus 48 times 3. And the calculator would tell us that would be negative 306. Okay, so the first three terms of the sequence are negative 54, negative 144, and negative 306. All right, and that will do it for this video. Okay, that was bad. I'm gonna erase that, but that will do it for the end of